Hi. Hello everyone. I'm Fuyutaro. Today I'll present OpenJPY commercial settlement layer. Stable coins are now available in Japan. However, using stable coins for payment comes with challenges. The problem of transparent transactions become critical when used for commercial settlement between enterprise. All transactions visible to competitors. Pricing strategies exposed and supply chain relations revealed and cash flow patterns observable. That's why in commercial settlements, compliance preserving privacy transfers are needed. Unless we can realize architecture on public chains that meets these nodes, a banking wire transfer will never be replaced by blockchain. Okay, and how can such a UX be achieved? This is the most established UI for C2C payments. We want to achieve this user-friendly UX on public chain. To enable commercial settlement on public chains, we need to meet these three requirements. Compliance preserving. The second, privacy. Only membership can be viewed. And number three, credit advice. Immediately detection upon transfer. And let's first set up the situation we want to solve. Alice belongs to a company, and on the email address alice@aa.co.jp. Alice also holds a crypto wallet of A company. The same applies to both and B company. The shared pool is the on-chain privacy fund commonly used in OpenJPY. We want to complete a transfer from A company to B company without leaving any traceable footprint on chain. This is the challenge we are solving. Step one, registration. Alice, using Relayer, submits a credential-proving ownership of alice@aa.co.jp via GK email. This adds her a view key to the domain registry and add her to the on-chain domain-based address book. Domain registry and domain-based address book. Everyone can verify company information from that domain, creating an anchor for KYB evidence. Here is a good news. .co.jp is an email domain managed by the government as the authority. If we limit the scope to .co.jp, only registered corporations can be obtained. By limiting the scope to .co.jp, this shell pool becomes a government guaranteed compliance space on public chain. Second, deposit. Alice uses a public address like alice.is and submit a membership group for allowed list addresses. She deposits 100K USD, 1 JPY into the shared pool, update the commitment anchors, and create private threads A. And insert the node commitment and the ciphertext. This process is based on common idiom shared pools like Gcash, but we add an email domain gateway. The status ID utilize the announcement to find in status address ERC 5564 status address standard. This status ID has status ID has a special property. Only the owner can scan and detect it with their view key, while no one else can identify it. As I'll explain later, this trace ID is used as a marker to make it easier to scan your own balance. Step 3, transfer. I'll use a layer to submit membership group to allow receipts and transfer transaction, which is the idiom of shared pools. This specifies which node to spend with commit in the private input, submit and notifier to prevent double spending, and provides membership group to anchor showing the node to spend is valid. Now, once the transaction is verified, the anchor and the notifier set defined in the shared pool are updated. At this time, similar to the deposit in step 2, we create private thread A and B, insert the status ID into the status ID set using the status address approach, and insert the commitment ciphertext of a newly issued node. Transfer for subsequent times, reuse private thread A and B. The process is simplified. We reuse the already established thread and insert commit and ciphertext into it. Now, let's check if the architecture we've seen meets the properties we want to achieve. First, compliance preserving. Only users who have been pre-registered by email domain can access this pool. Again, if limit to .co.jp, the authority is the government. This ensures a compliance level equivalent to KYB AML CFT. Next is the privacy. The ciphertext in private threads can only be decrypted by the receiver, similar to traditional sealed pools. In the future, we should be able to design viewing keys that support adding and removing member from thread. What about being private thread? Transaction signer for private thread and limited layer on paymaster that sponsor gas. Also, the status IDs placed in each thread are all unique. This ensures private thread A and B and private thread B and C are linkable. Private A and B and B and C are unlinkable. Preserving the confidentiality of transaction relationships. Finally, project advice. This is a problem directly connected to user UX. User will feel anxious if they can't track their balance in real time. In existing sealed pools, all members worldwide are essentially sharing one big thread. They had to scan every commit and ciphertext on-chain and could only learn their balance when they found one's address to them. To put it extremely, you'd receive all commitments worldwide on your mobile and search for your inside your mobile device. はい、ありがとうございます。はい、では、次に、Fuyutaro の OpenJPY の Fuyutaro 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 の OpenJ By contrast, in our approach, you only scan the threads relevant to you and tap into ones you belong to. It's as if the threads themselves are shared. I'll just check one thread. And I'll check one thread. Object to threads. I cannot check one. And not thousands or millions, just your actually business relationship. This is the same design as existing manager apps. This is the same design as existing messenger apps and should achieve good UX without sacrifice real-time performance.
Okay, thank you, Yutaro.
I end this.
So, any quick questions? Uh, yeah, I love your idea, and I need this for me. So, I couldn't understand the specifics of, I mean, the technical detail for now because my uh, knowledge was not enough. Can I have this slides?
Uh,
Yeah, we can share it. Okay, that's okay. Thanks. That's it. Yeah, yeah. Any other questions?
Thank you.